Welcome back, everyone. Today we're going to be solving LeetCode 804, unique Morse code words. International Morse code defines a standard encoding where each letter is mapped to a series of dots and dashes. So A maps to this, B, C, okay. For convenience, okay, it looks like they give us an array of all the mappings from the alphabet to their Morse code character representations. Given an array of strings, words where each word can be written as a concatenation of the Morse code. Okay. Cab should be this, which is C, A, and B. Alright, and they want us to return the number of different transformations among all the words we have. Okay, so let's take a look at the examples. So it looks like Jin and Zen both map to the exact character representations, and so do gig and message, and they're only outputting 2 because we only have 2 different character representations for all 4 words. Okay, so we know we're going to use a set at some point. Okay, so let's get the alphabet first. We can do that by using string.ascii. Are we using all lowercase? Yes, we are. So we'll say ASCII lowercase. So this will give us the alphabet. If you don't believe me, we can print it out. Print alphabet. We can run it. And there you go. We get the alphabet. So I think the easiest way to approach this is going to be to create a mapping where inside of our mapping it's going to be the alphabet character mapped to its Morse code character representation. So for A, it would look like this, and then so on and so forth. So how do we do this? Well, we can just take this, because this array contains all of the character representations. Let's make this a bit easier to read, and we'll call it Morse code. I guess is fine. Okay, now what do? Now we have to somehow create this mapping. Well, we can do that by a for loop. So let's say for character in alphabet. What do we want to do? We want to set that mapping character as the key, and the value needs to be the Morse code. Well, how can we grab this without having to do a nested for loop? Well, we can use a pointer, set it equal to 0, and then every time we iterate through alphabet, we'll just also keep track of pointers. So for A, it'll be 0, which will give us this. Go to B, we can increment pointer, it'll also give us this. So now we can say Morse code of pointer. And then at the end of this, we'll just increment pointer. Now let's print out our mapping. And there we go. So now we have a mapping for the alphabetical characters to their Morse code representations. So now what do we need to do? Well, now we need to iterate through our list of words, and for each word we need to build out the character representation. So we can use another for loop for that. We can say for word in words. What are we going to do? Well, we want to build a new string. So let's say new string is going to be equal to an empty string, because we want to do this for every word in words. And let's also define our set, which we will add our character representations to. This will keep track of all the unique ones. So now what? For word in words, we need to grab the character. So we'll have to say for the individual characters in the word, we want to say new string plus equals what? Mapping of that character. So this will give us, so if we're at G, for example, in Gin, if we're in Gin, we're going to grab this first character, and then we're going to add the Morse code representation to our new string. So if it was A in this case, AIN as our first word, we would have A here, and then we would just append dot dash to our new string, and then we would continue on to I, and then add it to this string, and then N, and so on and so forth. So after we finish, though, when we get to the end of the word and we've appended the last Morse code character representation, we want to add that word to our set, right? And the easiest way to do that is just going to be to say if our new string is not in our set, what are we going to do? Well, we're going to add it. And then at the very end, we should have all of our unique character representations within inside this set, so we can just return the length of the set. That should give us the right answer. Let's run it and find out. Yep, looks like we're passing both test cases. Output 2, 2. Output 1, 1. All right, let's submit. And it does run. So, okay. So what are the time and space complexities for this problem? Well, the time complexity should be, well, this loop is going to run O of n, so let's put that here. And this loop, so we're looping through every word in words, and then we're looping through every character in each word. So this entire block should be O of our words dot length times the length of the word that we are currently at, and then so it should be word dot length. Why do I say that? Because we have to run this loop four times in this case, and then we go into another loop where we're running it 3 times, all 4 times in this case. So it's going to be the length of our words array multiplied by the length of each word that we are currently at. So in this case, it's we have words of length 4, and then every word is of length 3. But every word could be, a different length. We could have a length of 1, a length of 10, etc., etc. So the time complexity should be the, like I said, words of length times word dot length. And the space complexity should be, what do we have for space? We have a set and a mapping. So our space complexity, I want to say, is O of the length of our output set.